Hello, welcome to NoteFlow. This is Group 25 for CSE 412 Database Management Phase 3. My name is Brandon Lim, and with me are Sahil Pai, Sarish Tiwari, and Sahir Khan. And we're going to be telling you about NoteFlow, which is our full stack note-taking application built with Vanilla.js, Flask, and Postgres. So let me quickly show you our database foundation here. We have 5 interconnected tables. So we have users for accounts, user stats for metrics. We have notes for content, tags for categorization, as well as note tags, which is our junction table for many-to-many relationships. So we've implemented cascade constraints for automatic cleanup, check constraints for data validation, and indexes on frequently queried columns for performance. So let's explore the user interface a little more. So if I, for example, want to register, I can enter my name, email, and password here. If my email already exists, it will promptly show the user that email already exists. So if I do log in with my account, you can see that I have my notes pop up. I have my filters pop up, which I can use to filter any notes right here. So we have status, the search query itself, and the tags as well. So I want to search certain note, I can do that right here. And I also have statistics right here, which shows our total notes, active, pinned, archived, and tagged statuses right here. And uh, I'll be showing you one of the CRUD operations here, which is creating a new note. So if we click new note here, we can enter our title right here. So we can enter our title as well as our note content. And we can also select a tag right here, select multiple tags as well. And it'll show up in this nice grid format here. It also shows you the modified date as well as the pin, archive, or delete feature. So you can, for example, pin and it'll update accordingly in the statistics page. And also archive it as well, which will gray it out, but we're always able to access it and unarchive it later. And yeah, so that was the create operation for NoteFlow. I'll hand it off to Sahir now for more of the UI features. Thank you.
Thank you, Brandon. Now let me demonstrate the filtering and search capabilities from the user's perspective for NoteFlow. And so the interface is going to instantly filter notes, searching both titles and content of the notes. And so that's like a GET request to our search endpoint with the query parameter. And so first I'm going to just show off all the filters that we have. And so we have search, status, and tag. And search notes is obviously going to be for searching through the notes. Status is for, the different statuses that we have, like active, pinned, and archived. And then tags is going to be the numerous tags that we have on the notes. And so you can already see that I have a couple of notes in here with different tags. And you can pin, archive, and delete either of them, and like they're both active right now. So first things first, just for searching through the notes. So say I like search the word laundry, then I'll show the only note that has the word laundry in it and exactly what we wanted, front and center. And then now if I go to the statuses, so obviously both are active right now, but if we want to change that, so let's say I want to like pin this note, all I have to do is just click pin, it becomes yellow, easy to see, and now it says pin. And I can also unpin it whenever I want, but let's just keep it pinned right now. And as you can see in the statistics bar, that's also changing real time. So if I unpin it, it becomes 0, but if I pin it, it becomes 1. And so now if I filter through, so let's say I just want to see the pin notes, they'll show 1. But now let's say specifically I want to see the notes that only have the tags, like checklist, they'll still show up. But if I pick another tag like event, it'll go away because it didn't have that tag. And so all these filters are just for really good querying for the user. And so now if I were to edit one of the notes, so let's say I do things to like this note. So let's say I change the title to things to do. And let's say I add like get pencils. And then now let's say I add another tag, like let's say learning, save the note. As you can see, it updated instantly. The new tag learning is now here and also shows the timestamp. And as you can see, get pencils is now in there too. And so that is when I saved the new note, the front end put request with all the data, and then the backend updated the note table and managed the tag associations. So now I'll just show you a complete workflow. So now if I make a new note and let's say I name it grocery list, and then let's say I put in, eggs, bacon, and toast. And then now let's say I put the checklist tag on here and then save note. As you can see, it immediately pops up. Everything is in there, and I can pin, archive, or delete it. So if I pin it, it'll become, pinned. If I archive it, it'll become grayed out, but it's still here to like edit or whatever. So I can unarchive it. And then now if I delete it, then it'll ask, do I want to delete it? And then it'll be deleted. And as you can see, it also changed in here. The total notes went from 3 to 2. And I can also, right now, total notes are 2. If I delete it, if I delete this note, bam, the total notes go down to 1. And so the confirmation asking if you want to delete or not prevents any accidents. And then the note is removed from the database along with all its tag associations through Cascade. And then we saw how the statistics sidebar changed in real time for every update. And so the notes count, decreased when each note was deleted. And that comes from aggregate SQL queries that run after every operation. And so as a whole, the interface is just designed to be easy to use for users. And so now I'm going to let Sahil show you the backend powering all of this.
Thank you so much, Sahir. So let's go look at the backend. Noteflow uses a Flask backend with Postgre connections, and all database credentials are also stored in environment variables for security. So let's show the JWT decorator here. We use JWT tokens for authentication. The decorator protects routes by verifying the token from the authorization header. If valid, it extracts the user ID and allows access, and obviously, if not, returns the 401 error codes you see here, 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 and here. Um, on top of that, I also want to show you the register route here. This is how we register an account. When users submit the form, we can validate the input. Obviously, here to hash the password with bcrypt. You see that right here. And then on top of that, we also insert them into the table using parameterized queries right here, which obviously are protected against SQL injections. We also have error handling by creating unique violations. So you can see them here, for example, returns a 409 error code, right? These are obviously authentication issues or database conflicts and registration failed here. The 500 error codes signify server-side errors, which are a lot less common. And on top of that, I also want to show you guys the create note endpoint right here. The create note endpoint here is how we create our notes. So essentially what we do here for that is we're able to insert each tag ID into an array. And if it doesn't exist, the foreign key catches the constraint, catches it, and we can roll back the entire transaction. This ensures pure atomicity. So either the note is created with all its tags or nothing happens. And obviously, we can update the user stats table as well to show this here. With the update user stats table here, you can see that right there, as well as happens in multiple fields, update note, etc. And essentially, what that does is it maintains and counts the distinctive active tags. And finally, we can also commit the transaction, and all this is wrapped in try catch blocks. And if anything fails, we can still use con.rollback to maintain database consistency. And of course, we never want to leave the database in a partial state. This demonstrates key backend principles, shows parameterized queries for security, decrypt hashing for protection, transactions for atomicity, foreign keys for integrity, obviously comprehensive error handling. And now I want to pass it on to Suresh, who will show you the select, update, and delete operation.
Thanks, Sahil. My name is Suresh Tiwari, and I'll show you the rest of our query operations. So first up, we have our notes API, our endpoint here. It'll grab all the notes for each user. So we have a select operation, which will grab the different note fields that we want. Left run with the node tags junction table that will match the note ID to each user ID to make sure we're getting the proper notes for each ID. So I'll quickly refresh the page here, which will trigger our endpoint for the notes, which will grab all the notes that we have. As you can see, if we were able to process this completely, and it brought one note, our new test note that we have currently. So I'll quickly show you our notes table to ensure that it's matching up with what we see on the dashboard, and it does. We have one node called new test node. Next up, that was a select query. I'll be showing you the update query. So basically on the dashboard, we can click on a note and we can call it old test node, for example, call it this is for testing base 4 and save it. So this will call notes and it'll call the notes endpoint and update the information with the note with the update query. And we can double check this by running by checking the notes table by running the select query, and we can see that yes, our title and content were successfully updated in the background. And of course, we have deleting with Cascade. If we make a note, for example, that has tags reference with it, we want to make sure that once we delete a note, it'll delete the respective rows within the note tags column to ensure that all tags associated with the note are also deleted. So we'll quickly say new note tag, and this is an important note. We'll associate the important tag and save note. It's calling the tag note endpoints to ensure that we're associating the proper tags with the notes in the note tags junction table. So we can go over here and check, yes, our new note does exist. And we can also check our note tags table to see that, yes, this tag is associated with the proper note ID. Now, if we were to delete this note, we deleted this note from the table by calling our endpoints respectively, and we'll quickly check the note tags table. Of course, this has been deleted, and we can see that it has also been deleted from our notes table. So these were our select, update, and delete queries. Overall, every query in our table is going to use parameterized statements for SQL injection prevention to ensure safety and security. And we're also going to have a lot of check constraints to enforce business rules and valid email format, status values at the database level. And yeah, thank you very much for listening. I hope you have a great day.